Well, thanks for joining me, everyone, today. As you probably know, I want to spend a bit of time just showing you what MapleSim is about. So we'll do a quick introduction to modeling and simulation using MapleSim. I'll spend a little bit of time first just speaking about the motivation for why something like MapleSim even exists. And a lot of it centrally has to do with how we fix design issues or how we improve designs and when we would do that in a product design cycle. So what you're seeing here is just a general sort of conceptual understanding of what it might cost to fix an issue that you might come across in one of your designs, just depending on where you're at in the design phases. So you can imagine that if you're all the way at the beginning there in the concept area, you find some issue that's maybe not going to work out, it's going to be pretty simple to fix. As you march further along, even if you get all the way out to like releasing this product to market, whether it's a machine or what have you, the cost just grows exponentially. If you're in the sort of, say, machine industry or industrial automation, you might have to shut down whole lines. So the cost gets huge. And finding these costs in this blue area to the right, this is usually where you're going to find issues without model-based techniques. You know, you're looking at the physical prototype or the product, and that's where you see the issue come out. But on this side, this is where you're typically going to use model-based techniques to find your issues. This will be using tools like MapleSim or perhaps CAD or FEA tools. But this is where you're typically finding your issues before you've got a physical prototype. So as you could guess, it's going to be a lot less expensive to do that. And in some research, this was sort of going back and analyzing decades of NASA programs and where the costs were and what the project cost overruns look like. And it looked like, for their perspective, that if you're able to spend just a bit more upfront on, say, the conceptual and system design area, say 5 to 10% more, this can reduce the cost overruns of the whole project substantially, 50 to 100% in many cases. So this kind of motivation and thinking is why we care about system-level modeling and simulation. And just to describe what that is, because there's lots of different kinds of modeling and simulation that exist out there, and you're probably familiar with a handful already. But system-level modeling is modeling of interactions that are across all the different subsystems in your design and the dynamics of those. So how they actually come to life and how they perform and behave and interact with each other. This is how your hydraulic system is going to connect with your mechanical system and how the forces from a hydraulic cylinder move into the mechanical world. You could put some batteries in some part of your design to move a motor. So it's how all these different systems actually come together and work or don't work together. This is good for organizing the knowledge between all the different domains to see if there really is a good tight fit between everything and to see if your designs are going to have any potential issues. Often for especially complicated products, you've got a lot of teams of different engineers working on different aspects of that design. So if you're able to have a system level modeling tool where you can plug in the most important parts of each domain, it ends up being a really important way to understand how validated your design is as you start marching forward to that first physical prototype stage. And it also helps reduce the cost of other kinds of prototyping iterations, CAD and FEA iterations. Let's say, for example, in this tool, we have a heat transfer library. You can sort of model on a high level how heat is moving around and then narrow in your design space before you need to really unleash days or weeks, at least, of heat transfer analysis in FEA. So it helps get you to the prototyping stage sooner and more reliably. And for those of you who aren't too invested in any particular simulation or modeling tool right now, perhaps you know from your experience that using spreadsheets works very well for just all the calculations and all the traditional things that you do in your design process. But you probably are well aware too that there's a lot of reasons why those end up failing. So you've got to pass them to a new employee. or you just end up making some simple human error in one cell, and then that gets undetected for days. So by adopting a bit of a modeling tool, you're going to have a better chance at ironing out all those errors too. So MapleSim is a system-level modeling tool. And what comes with that is actually, it's a really large set of features and abilities for how you're going to try and understand the dynamics of a multi-domain system that you're designing. And what we've designed MapleSim to be really great at is making it more intuitive and easy to use than many other tools in this space. If you have any familiarity in some other tools in this space, you know that they're not always the easiest tools to use. And of course, you're designing complicated products, so these things will never be simple. But we've designed this to look as much like your product as we can. And because of that, we let you import your CAD into MapleSim as a great starting place. We give you 3D visualization of how your part or how your product is going to perform. And we have a lot of different built-in tools for many of the common tasks that our customers are interested in. So if they're looking to size a particular component in their design, let's say a motor, we have tools that allow you to, with controlling the parameters that are important to you, to optimize for a particular objective function, such as what is the smallest motor that I could get away with, given my other requirements. So we have a lot of different tools and optimization templates that allow you to do the analysis that you're looking for. And we've made it really easy to use with the rest of your tool chain. So if you're looking to, say, take this wonderful model you've made that you know gives you a pretty clear sense of what the loading capacity on something will be, then you can go ahead and, if you're doing any testing in Simulink, you can bring it over there. There's an increasingly popular standard called the functional mockup interface. And if you're familiar with that at all, especially in the automation world, you can take these models and you can stick them into your control design tools. And now you can see if your control code is going to work against an actual physics-based model. So there's a lot of different ways that you can use MapleSim, and enough said about that. I'll start showing you that in just a minute. I thought a quick video just to give you a starting place that many of you might be familiar with is just simply bringing your CAD into MapleSim. So for many people who are in product design, you know that there's going to be CAD of whatever you're building. So this is just a sped up video that is us bringing a CAD file. We work with all the major formats, and we're in MapleSim right now. We're just importing this CAD, and all we're doing is we're just doing a quick process where we're establishing where our particular coordinates are for where things move. We're just quickly defining what is rotating around what and what is going to be rigid. And that's it. You just had to click through a couple of the key places where we move. MapleSim is going to bring in all of these sort of mass and inertia data. And then, because now I'll just move on to showing you what that looks like in MapleSim, that model that you saw in CAD, this is what it ends up looking like. You can see here the different parts. And then in between these, you can see the different joints that describe movement. And this is how someone would sort of get started in MapleSim, is by bringing their CAD in with just a few minutes of clicking. But we're getting a bit ahead of ourselves because I thought we'd start with a simpler model to just describe what MapleSim is and what it's doing. So you're looking at MapleSim's main interface here. In the middle is the modeling environment. And this is a drag and drop environment where you can just have a variety of components. They're connected together in intelligent ways, which just means you can't connect an electrical component directly to a magnetic component if it doesn't make sense through the physics of it. There are times when you make those cross-domain connections when the components make sense to do so, but MapleSim makes sure that what you're creating is physically meaningful. You get your components from on the left here. So MapleSim comes with several hundred pre-built-in components spanning all different domains, from electrical, hydraulics, multi-body components, and the list goes on through battery, driveline. So we have a lot of different component libraries depending on the kind of modeling that you're looking to do. So if we were to open one of these up, our mechanical library has rotational and translational components. And within that, you can drag from your, say, your common components. If you wanted inertia, you could just bring it in like that. And the list really does continue. And if you're just looking to search for a component, you could just type it in up here. And there are the components that you'll be able to pull from. So there's our modeling space. Now let's say I click on this here. This is a rigid body, because the model you're looking at here is a very simple 2D rigid slider crank. So there's two links, and they're both fixed to the same plane. And then there's a joint between them. And this here is the prismatic joint, which provides the translational motion. And then these collection of components here essentially make up the link. These define the length of the link. They're just known as rigid body frames. So they describe a rigid frame that we then use in the middle, this rigid body, which is where we describe the mass of that, the moments of inertia, and all sorts of other parameters in this parameter pane to the right here. So any component you click on, you'll see there's a lot of different ways that you can customize them to what you need. But if you don't need them to be extremely precise, the best rule is just to leave the parameters as they are, because we fill in our sort of the best guess for what the default parameter should be. And then you can go and add fidelity if you really need to, say, adjust increasingly detailed parameters for that component. So the way that we would create this is we would drag in the components we need. We would then start creating connections between them like that. These are already connected, but you just click between to create your connections. And there's one other thing that I haven't described in this model here, which is this here, this probe. So there's a lot of different variables that are running underneath this. This is essentially a system of mathematical equations that MapleSim is very good at solving. Whether it's going to be a system of 100 equations or 100,000 equations, MapleSim has the best symbolic equation processor on the market. So that means that when it's time to actually perform the real simulation, where you're plugging in numbers and you're performing that numerical integration, it's going to run very fast, and you'll see that in a minute. These are probes we attach just to say, hey, I'm interested in seeing how the length of this link is going to vary. So when everything looks good, now you kind of have a bit of a clear sense of what, in general, MapleSim is. When we're ready to simulate, we would just press this play button up here to click Run Simulation. And then down here, as you see all these different details fly by, which is just to mean that you're able to go and see exactly what's happening. In a matter of seconds, what MapleSim is doing is it's running the simulation and it's giving you an output of what this rigid slider crank system is doing over the course of 10 seconds, which is also a parameter that you could adjust from fractions of a second to weeks. So you get a 2D plot here, and you get a 3D animation. Now this is a very simple animation, and you'll see what I mean when we start using nicer looking models. But this is a very simple animation to just show you that model we were just looking at in MapleSim now looks like this in 3 dimensions. You can see the 2D plot is showing you what the length of the slider crank is doing over time. And of course, as you can see, it sort of oscillates back and forth, and that's the same behavior we see here. For any of you who are familiar with our other tool, Maple, our calculation management software, you might kind of feel like these plots look very familiar. And that's because MapleSim is based on Maple, and it uses the same mathematical engine in Maple. It uses the same plotting interfaces. So MapleSim and Maple are very closely connected, which means that the 30 years of development that we've put into how you can work with math and results in Maple, you can do all of that with MapleSim 2. You can even bring your model into Maple and do whatever sort of analysis you're looking for. Okay, let's make our model just ever so slightly more complicated. Even though it looks more simple, perhaps the right word is let's just take advantage of a few newer features in MapleSim. So this is a 3D pendulum, and it actually is quite simple. And the reason that it looks so simple, even though it's still a multi-body moving model, the reason it looks so simple is because we have what's a new machine elements library, which is a variety of new components which come with built-in understandings of their masses and inertias, and even some built-in CAD. So this is just a very simple, great, here is a flexible rod, we have a mass at the end, and very simply put, this is what we'll see. Again, just to give you a sense of what a modeling tool like this is all about in its most basic sense. So this is just a beam with a mass at the end, and it's just sort of moving around. And there's not too much more complexity beyond that. But you can imagine how perhaps in a more complicated model, you may have some degree of this kind of behavior in a more complicated system. So then you're just free to add more complexity to your model and continue to work in the building blocks that you're making. So with that being said, let's just move over to the model that I first showed you. And that is this pick and place machine that we brought in with our CAD. So this is still, it's still a fairly simple model. Part of that is really thanks to importing your CAD. And while that's not necessary, and MapleSim will always give you a visual representation without CAD, this means that all of these components, and these are all the pieces of our CAD, they have contained within them a whole bunch of data that would otherwise have to be broken out into several components. So in here, we do have all of our mass and moments of inertia. So the job here for the MapleSim user is just to then say, well, between this piece and this piece, we know that there is a revolute joint mechanism or motion here. So we'll put that in. And then we'll go ahead and say that between these, we know it's a translational movement, and we'll go and we'll connect all that up. One component I did want to point out in MapleSim is this parameters component here. And what this is doing is it's recognizing that when you're making a model that's going to have several components that are the same, let's say you have a duplicate subsystem and you know that, well, the mass is going to be the same in these components, but I want to know how the system might perform if I change that mass. So for that reason, you can use this parameters block, and then you can define parameters. So we'll call one mass load, and this other one cycles per minute. You could define a whole big list. These are important to us for this machine. And then because we have these, we can go along and say, well, now the mass load is 1 kilogram, and wherever I need to reference the load of my the mass load in my model, I can just type in mass load. One way that you could see that here would be this here is a constant speed input. What this is doing is this is the component that's driving the motion in our pick and place mechanism. You'd be free to actually go into your electrical components, and you would be able to start putting in, if you wanted to, you could put in DC motors. We have things like that. You could start putting these things in. But for this model, the goal of creating this one is to understand the torque responses at different places. So we know that we want the thing to be moving at a constant speed, but the speed itself, we're just referencing as a function of the cycles per minute. And this opens up some possibilities because when we start analyzing the model, we can just refer to CPM and MapleSim will take care of the rest. And we don't have to worry that we've forgotten to update something somewhere along the way. So that's this model. And I'll show you what that looks like in the results manager. So now you can see that this looks a lot better than the past two. It looks like there's really something meaningful here. And I'll click this here for you. And now you're seeing the operational cycle of this machine. And again, all these pieces came from your CAD tool. We just brought them into MapleSim, and we brought them alive in a very physically meaningful way. This plot over here, if we hit play again and watch it, what you're seeing here is you're seeing the torque requirements of a motor that would be in the position of that constant speed area. So we're seeing here what the torque results would be on this motor. And now these are nice plots to look at, but of course, if you're creating a more complicated product, you need access to all these specific data. So it's great that MapleSim knows at every instance of time what the loading requirements will be. Of course, you're going to need to go into more depth than that. So this is great for doing quick, like what-if analysis, for playing with ideas and for testing out theories. But if you really want to start getting into the numbers, then MapleSim provides a variety of templates that allow you to do the analysis you need. So these are all the different built-in apps and templates to help you with analysis. So for example, in the model analysis area, you can extract all the equations that govern all of the phenomena in your model. And they'll be long. For many models they are, but perhaps you might need that to do something. And then we allow you to do lots of other things here, like just do a parameter sweep to say, well, let's just vary how fast this thing goes by a huge order and watch what happens to the rest of our system. So we give you a lot of different ways in which you can analyze your model, but you could even build custom components so that if you know, well, there's a particular thing that you want to be able to model, but we don't have that, as long as you understand the phenomena of what governs that, we have a nice smooth application that lets you input the different equations, and then before you know it, you have a block that is the component that you're interested in. So outside of all the built-in applications, one thing that's nice about this model is we've created a built-in analysis worksheet to deal with this click-and-place motor. And this is because MapleSim files, they act as essentially like zip files in some sense. So you can bundle in all these sort of analysis that you do and everything that relates to your model. So when you need to share this with people, it's just a single file that you can move around. So this analysis worksheet right here, this is built into our MapleSim file. And I'll just go over here. And this is that file that we just opened. And again, for those of you who know about Maple, you'll notice that we're just inside of Maple now. So this is our other flagship tool, Maple, which again is a completely fully functional computer algebra system, document manager for technical calculations, and many more things. And we've made sure that MapleSim works very tightly with it. So in this, we've inserted a component or a frame into Maple that has our entire MapleSim system in it, which means that now when we hit simulate, we're able to just pull out all of the nitty-gritty stuff that we could ever want for how we would work with this model. So in this template that we made, we knew that the main design goal here was to figure out the different kinds of torques that are going to be required for a particular motor. So we need to figure out what those requirements are. So after simulating this within Maple, come down here, and we have all these different these results that we could plot. So let's just say here, if we're looking at the motor torque, we see that over the 10 seconds of simulation, we can see the response here, which is this red line. And then we've just added in some other important variables when it comes to motor sizing. We have our minimums, our maximums, and our RMS value, which is averaged right here. And a bit further down then, this is what I meant when it comes to parameter sweeps and optimizations. You could go deeper with this in our other template, but if you just simply say wanted to analyze how your motor torque requirements would change, we've created this where just by using standard built-in components in Maple, these sliders we just dragged in right off Maple. And because of that, we can say, oh, let's just vary our mass and let's see how things are changing. And you can see that the absolute torque numbers are changing quite a bit. if our mass load was 10 kilograms versus a very small 1 kilogram. So with that being said, another thing you might want to do is vary how fast this machine would go. So let's say you just simply are interested in the maximum torque requirements, because you need to know what motor would sufficiently cover the entire operational range of the machine. So we'll unclick this and say, well, let's just vary our cycles per minute from 10 to 50. And now you see this nice curve, which is showing you that, well, at 40 cycles per minute, we're roughly at about 43 Newton meters, our absolute torque. And maybe we want to change that to 100. And then you can start to understand how your motor choices would be impacted by how fast the machine would go. So that's just one potential workflow for how you could use MapleSim. If I was to click on the help here and examples, this is just to give you an idea of how, in a short presentation like this and in a short introduction, it may seem like MapleSoft perhaps is simply to do with slider cranks and pick and place models. But the reality is we have models that range from electrical domains to hydraulics. We have different kinds of magnetic domains, and even thermal for heat analysis. And as you continue on down, you can see that there's a wide variety of what can be modeled in MapleSim, which is why for any 30-minute presentation, it would be hard to fully convey that. But I hope what I have showed you a little bit is just the typical workflow with how you would use a tool like this and how you would drag and drop the pieces you need and how you would slowly build up to something that it becomes relevant to your product and allows you then to start getting meaningful results out of it. And ultimately, going back to that very first slide from my presentation, how you'll be able to get enough meaningful results out of something like MapleSim that you'll catch that important design error earlier than you would have otherwise, and ultimately save you a lot of headache and cost and pain down the road. So that's why we built MapleSim, and that's why we think it's a really powerful tool for engineering design in so many domains. And I hope you see that too. That was the demo I wanted to show you today. I'm happy now to open it up to some questions. And perhaps one question, just to kind of get this started, that you might have is just simply, well, perhaps you don't have the expertise in using a tool like this, and you're just wondering how you might get started. We recognize that, and we have a dedicated set of team here at MapleSoft that help provide any degree of support that you need to get going. Whether you have just a particular pain point and you don't have any of this expertise, we could just help solve that for you. But if you're looking to be trained to some degree, we have a whole set of services to help you and help advise you about how this could work with your company or your project.